Hi, this is Rohan and welcome to another video by The Calc. So in this video, we'll be covering the April Fool's Contest number 3. And the April Fool's Contest was a contest that the Calc hosted on April Fool's Day. It was a 4-question Olympiad contest, which each problem was worth 7 points each. And the winner got a Discord Nitro Classic. So this is problem 3 out of 4. And let's look at what the problem statement is. For some positive integers x, 2x and 5x have the same leftmost digit y in the base 10 number system. Find with proof the possible values of y. So we have 2 to the power of x. Oh wait, I think my pen mode is off. Okay, yeah. So we have 2 to the power of x and 5 to the power of x. And we need the leftmost digit to be the same. So there's 2 reasons why just listing out values of x and trying them out doesn't work. The first reason is it's really hard to do it because the numbers get exponentially bigger. Like they go up really fast and calculating will take a lot of time. The second reason is it's an Olympiad contest, meaning you have to prove that these are the only values of y that work. And it's not possible to just say, oh, these are the only values of y that work, and you have to assume that. You actually have to prove it. So let's start by defining 2 variables, a and b. Now the reason I did that is we can write these 2 equations. Y times 10 to the power of a is less than or equal to 2 to the power of x, and that's less than y plus 1 times 10 to the power of a. And we can do the same thing for 5 to the power of x. Except we're using variable b this time because they have different values, and 5 to the power of x is definitely going to be more than 2 to the power of x. So a and b cannot be the same. That's y plus 1 times 10 to the power of b. Now that we have these equations, you're probably wondering why we just introduced 2 new variables, because more variables usually means there's more work to do. I'm just going to darken this a bit. But the reason we're doing this is if we multiply these 2 equations, which gets us y squared times 10 to the a plus b is less than or equal to, and this is a key reason we're multiplying it. Like this is a motivation. It's because if we multiply 2 and 5, we get 10 to the power of x. And we also have a power of 10 here, and once I finish writing out this side, we're also going to have a power of 10 here. 10 to the a plus b. So now that we have all of this, what should we do? Notice that if we divide the inequality by 10 to the power of a plus b, the leftmost part of the inequality and the rightmost, they become with only one variable. So you get y squared is less than or equal to 10x minus a minus b, which is less than y plus 1 squared. And how does this help? So the reason this helps is because now we know that between y squared and y plus 1 squared, there has to be a power of 10. And we know that y is part of this set 1, 2, 3, all the way till 9. Because y is a leftmost digit. So it has to be from 1 through 9. And it can't be 0 because the first digit of a number can't be 0, or else that won't be the leftmost digit. And I think we released a clarification on this. The leftmost digit is non-zero. So that's another reason we should just leave 0 out of this subset. Now we can just try out all these values. And it's better to do it in your head than actually write it out, because writing it out is taking a lot of effort. And these are just their perfect squares from 1 through 9. And you notice the only 2 that work are n equals 3 and n equals 1. So you might think 9 works because then you have 9 squared, which is 81, and 10 squared, which is 100, and 100 is power of 10. But notice this is a less than sign, and this is a less than or equal to sign. So if there's a power of 10 equal to y squared, that will work. But if there's a power of 10 equal to y plus 1 squared, that won't work, because we have a less than, not a less than or equal to. So the reason we have these 2 values of n is 3 squared is 9 and 4 squared is 16, and there's a power of 10 in between them, which is 10. And 1 squared is 1, and 2 squared is 4. And 1 is a power of 10, which is 10 to the power of 0. So you might think, okay, we're done. We have our two values of y. Oh, I think I actually used the wrong variable. This is supposed to be y, not n. So I'm sorry if you got a bit confused over that. But I meant to say y. I'll just erase this and rewrite it. And this is y, and this is y. So what we can do now is eliminate this value of y. The reason we do this is if we actually plug this in, if we plug this value of y in all these three inequalities, we get that 2 to the power of b is equal to 5 to the power of a. So we need this to be true if we want y equals 1 to work. And notice that 2 to the power of b is an increasing function, and 5 to the power of a is also an increasing function. And since it's exponential, 5 to the a rises faster than 2 to the power of b. So they'll never be equal unless a equals b equals 0. Because then both of them will be equal to 1. And the equation is satisfied. But notice in the beginning, I defined a, b as positive integers. And 0 is not a positive integer. So this does not work. And that's why we eliminate y equals 1. And we get y equals 3. Thank you for watching the video. And at the end, I'll just clarify this before ending it off. That y equals 3 works. And I think the easiest way to check that is just try to find a value of x such that the leftmost digit is 3. And if you just try out a few values, notice that 2 to the power of 5 is 32. And 5 to the power of 5 is 3,125. And both of them have leftmost digit 3, which work. So that's actually the end of the video. If you have any questions, you can leave them in our comments or in our Discord server, which I have put in the description. And if you want to view the full April Fool's test, I've also linked that in the description. Thank you for watching the video. Enjoy the rest of your day.